Okay, hello again, folks. This is our second lesson of the new unit factoring. Here is a little breakdown of what I'll be doing. It'll be quick. I'm going to try to make these lessons as quick as I can. I will say, though, that this might be the most important lesson of the year. And I think for some of you it'll be really, really easy. But I do think for certainly a few people at least, this might be a very difficult thing to sort of figure out, mostly because a lot of people aren't very good with their times tables. If you have your times tables memorized, this should be pretty easy. So what I would like to do, just like we do in class, I want to start with the opening question here, and this will be based totally on the lesson I posted on Sunday, which was Monday's lesson. What I'm going to do from now on, I'm just going to post the lessons on the morning that they're supposed to be given out. So this will be Tuesday morning, so this will be Tuesday's lesson. I encourage you to try this question. I really encourage you to pause the video and try it and then see how you did. I think if you don't, if you just sit and watch me do it, you're going to feel like you know what you're doing, even though you may not. So please pause and try it now. Okay, I actually paused mine for some reason. I'm not really sure why, but that's okay. All right, so let's go through it. Remember, factoring, that's the name of the unit, so it's a pretty important term to know. It basically means put this stuff into brackets, and so far for us it means to take whatever we can out of all three of these terms and bring it out front. So first I'm going to look at the numbers. I've got negative 15, negative 20, and 35. So we're going to look at the number. I'll ignore the signs just for a second. So obviously 1 goes into everything. That's not helpful. These are all multiples of 5. And then I'll check 10, no, 15, no. So on the next line I'll put an equal sign like we always do to indicate that this is the same as what's above. And I'm going to take out a 5. Now, very important part about this, if the first term is negative, we will also take out a negative. It wouldn't technically be wrong if you didn't. It's just convention that we always take out that leading negative if we can. All right, now let's look at the a's. We've got a squared, a9, a7. So we take the lowest one. We can take an a squared out of everything. The b's, we've got b5, b2, b4. Again, b squared, or b to the exponent 2 comes out. c3, c, and c5. So we can take out a c. Okay, and that's my attempt at a bracket. It's a little hard writing on this little tablet thing. I'm sure you're experiencing challenges of your own. Okay, now each term separately will get divided by negative 5a squared b squared c. So first I do negative 15 divided by negative 5. That's going to be 3. A squared divided by a squared. The a's cancel out. There's none left. b5 divided by b2. Remember, when you are dividing powers with the same base, in this case the base is b, we subtract the exponents. So this will be 5 minus 2, or b to the 3. C to the 3 divided by c is going to leave us with c squared. Okay. Now I'm going to divide negative 20a9b squared c by negative 5a squared b squared c. So the negatives cancel out. 20 divided by 5 is 4, so I write plus 4. A to the 9 divided by a to the 2 is a to the 7. B squared over b squared, they cancel. C over c, they cancel. So our second term is just positive 4a to the 7. Now, 35 divided by negative 5 is minus 7. A to the 7 divided by a to the 2 is a to the 5. B to the 4 divided by b to the 2 is b to the 2, or b squared. C5 divided by c is c to the 4. Okay, and remember, if you have time, you can multiply this back through or expand it, and you should end up with what we started with. Okay, so feel free to pause, go back, watch that again. Again, you do have that option with this online video style lesson. Okay, next one. So this is not on your handout. The next slide will line up with the handout that I posted, but this is just sort of an aside, just a bit of a recap. So you're asked to expand here. You might remember that that means to FOIL. So first, outside, inside, and the last, so minus 18. All right, now I'm going to collect my like terms, and usually it works out that the middle two go together. Negative 6x plus 3x is minus 3x minus 18. If I asked you right now, what is the y-intercept of this parabola, I'm hoping you would be able to tell me that it's negative 18, because that's the last term here. Or sub in x is 0, these disappear. You're left with negative 18. If I asked what are the zeros, you would look at the factored form up here. The zeros would be negative 3 and positive 6. Hopefully you remember that from last unit. Okay, now you're on the handout. And on the handout, what I have given you is, I'm just going to put these all together on one page because that's how you're going to be seeing them. Okay, so I've given you this table where I want you to do the expanded form. And basically what I mean by that is I want you to FOIL them. Now, I really, really want you to do this on your own instead of just watching me do it and copying it down. I don't think that's valuable for you. And I'm going to pause mine and I'm going to write in all the answers. So it'll instantly just pop up for you. So if you're going to try them on your own, which again, you really should, please pause it and try them now. Okay, there are the answers. So hopefully you were able to pause it before they just popped up. So here are the answers, and we have two little follow-up questions that basically will kind of tell us how to do the lesson for today. So the first question is this. Compare the constant term in each trinomial, C. So let me just highlight the C's first. So that's positive 6, positive 2, positive 9, positive 12, 8, negative 3, negative 10, and positive 15. So the constant terms are C with the constant terms in the factors. And those are, sorry, that'll be confusing. Those are plus 2, plus 3, plus 1, plus 2, plus 3, etc. So I want you to compare those constant terms in the factors to the constant term at the end here. And what I'm going to do here is I'm going to pause it and I'm going to highlight all these numbers. You don't need to watch me do it. And I'm going to highlight them in a different color. Okay, so I have highlighted those. And these are the constant terms in the factors. And what I would like you to do now is compare 2 and 3 with 6. See if you can find a pattern. But the idea is that the pattern you find works for all of them. This is something you might already know. We've kind of already talked about it, but I just want to make sure it's very, very clear because this is a big part of today's lesson. So I'm going to tell you the answer in a second, so I would like you to pause it in a moment here and figure out the pattern. How are these numbers related to this number? So please pause it and figure that out now. Okay, and the answer is right here on the right side typed for you. The constant term C is the factors, the pink ones, multiplied together. Now we're asked to compare the coefficient of x, and I'm going to highlight those for you here. The coefficient, so plus 5, plus 3, plus 6, plus 7, plus 6, minus 2, plus 3, and minus 8. And we're asked to compare those with the constant terms. So again, that's the pink one, and this time it's the pink one with, sorry, it's the green ones with the pink ones again. So we're comparing the pink ones twice. So I'd like you to try and find the pattern there. How are 2 and 3 related to 5? It has to be the same way that negative 2 and positive 5 are related to positive 3, etc. So please compare each pink pair with the green number. And once this is done, we're almost done the lesson for today. Because once you make these connections, you might be able to figure out the rest of it. And again, there was a question on the last test where I had you actually do what today's lesson is, and a lot of you did figure it out on your own, which was super cool. Okay, so please pause it in a moment here and try to figure out the relationship between the pink numbers and the green. Pause it now. Okay, so the relationship is the coefficient of x, or b, what we call it, is the factors added. together. All right, so let's put these things together. And now what comes next, and this is the entire lesson for today, on the next page basically, we're going to figure out if we have this form, the expanded form, how do we take it back to here? And here's the idea. We know that this number, the 6, was these two numbers multiplied together, and we know that this number, the 5, was these numbers added together. So we need to find two numbers that multiply to 6 and add to 5. So let's move on in the handout here. So here we go. Use your observations in step 2 and 3 to factor the following. And what I'm going to do here is I'm going to give you a little mini note to write down. So I want it down here. To factor a standard form equation, and that is, remember, y equals squared plus bx plus c. And now you might notice that I didn't say ax squared. This a will come a little later on. So for now we're just doing ones where the first term is x squared. These are the easier ones. So to factor one of those, find two numbers that multiply to c and add to b. Now, the hardest thing about this is finding those two numbers. So let's do a couple of examples together. Now, I encourage you to try number 4, A, B, C, and D on your own. Maybe pause the video, try to factor them, and then unpause it and see how you did. But I will be talking through them, so you might have to fast forward. All right, so we need to find two numbers that multiply to positive 30 and add to 11. So if two numbers multiply to a positive, they're either both positive or they're both negative. But if those two numbers add up to a positive, they have to both be positive. So for those of you that don't know your times tables very well, go to the calculator, do 30 divided by 1 is 30. So two of our factors are 1 and 30. And then do 30 divided by 2. We get 15. So 2 and 15. Do 30 divided by 3, and we get 10. So 3 and 10. 30 divided by 4 doesn't work. 30 divided by 5 is 6. So 5 and 6. Now each time I should have been checking. 1 and 30, does that add to 11? No. 2 and 15? No. 3 and 10? No. 5 and 6? 5 plus 6 is 11. So this is going to be x plus 5 times x plus 6. And that's it. That is basically today's lesson. There's one other little twist that comes in a few minutes. But I find the two numbers that multiply to 30 and add to 11, and they are 5 and 6. And this is my answer. This is just a side. You don't need to write that down. If you can do this in your head, you don't need to do any of this. Okay. Now, part B. So part B is a little trickier. We need two numbers that multiply to 7 and add to negative 8. Okay. Now, again, if they multiply to a positive, we either have positive, positive, or negative, negative. But if the two numbers add up to a negative, they can't both be positive. So we need two negative numbers. So negative 1, so 1 times 7, or negative 1 and negative 7. Let's add those up. Negative 1 minus 7 is negative 8. So our answer is x minus 1, x minus 7. Now I often get the question around now, does it matter what order the brackets are in? It does not. Next example. We need two numbers that multiply to negative 24 and add to positive 2. Okay. If two numbers multiply to a negative, we have a positive and we have a negative. And now a little hint I like to give people right around now. If those numbers, one positive and one negative, add to a positive, did we have more positive or more negative? And the answer is that if they add to a positive, we had more positive. So the bigger number will be positive. So now I go to the calculator if I need to. 24 divided by 1 is 24. Can I make 2 by adding or subtracting 1 and 24? I can't. 24 divided by 2 is 12. Can I make 2 by adding or subtracting 12 and 2? No. If you're adding or if you're subtracting and you're getting 2, the numbers are pretty close together. But I'll keep going through it. 24 divided by 3 is 8. 8 and 3, can I add or subtract to make 2? I cannot. 24 divided by 4 is 6. With 4 and 6, can I make 2 by adding or subtracting? Yes. Now, I either have plus 4 minus 6 or plus 6 and minus 4. And if I add these, I need to get positive 2. So 4 minus 6 is negative 2. So that one doesn't work. 6 minus 4 is 2. And like I said before, the bigger number is positive. So this is x plus 6 and x minus 4. So for those of you that are getting a little worried or a little stressed out or nervous or anxious about this, it does take practice. And if you don't know your times tables, it will take longer, but you should be able to get it with some effort. All right, last example here. Two numbers that multiply to negative 15 and add to negative 2. Again, if they multiply to a negative, we've got one of each. And if they add to a negative, the bigger one must be negative. So let's go 1 and 15. 15 divided by 2 doesn't work. 3 and 5. We know that the difference between the numbers has to be 2. 1 and 15, I cannot make 2. 3 and 5, if I subtract, I can make a 2. I can make a negative 2. So let's try minus 3 plus 5. Negative 3 plus 5 is 2. I need negative 2. Plus 3, negative 5. So this one's out. 3 minus 5 is negative 2. So the answer is x plus 3 and x minus 5. Okay. So I'll leave that up when I go to the next one. So here we go. Factor each expression if possible. What I would like you to do is do A, B, and C. Don't do part D. Okay. I'm gonna give you a little tip for part D because part D combines yesterday and today. If you want to try it, feel free, of course. So I encourage you to pause it and try those now. So please pause now. Okay, so I did the first two, A and B. I'm just going to check it. X squared plus 8x minus 9x would be minus x minus 72. That one works. A squared minus 9a minus 4a would be negative 13a plus 36. And now let's do this one. So we need two numbers that multiply to positive 6 and add to positive 1. So if they multiply to a positive, we either have two positives or two negatives. But if they add to a positive, they have to be both positive. So 6 divided by 1 is 6. So 1 and 6, 1 plus 6 is 7. Doesn't work. 2 and 3. 2 plus 3 is 5. Doesn't work. But what you're probably going to do here, if you make a mistake, get rid of that guy, is maybe you'll say, well, I know that negative 2 plus 3 would give me positive 1, because that's positive 1x. But negative 2 times positive 3 does not give positive 6. It gives negative 6. So in this case, if you read the original question, it says if possible, and this one cannot be factored. And if you think back to what factored form tells us, you might remember that for this, the zeros are 9 and negative 8. The zeros are 4 and 9. What do you think the zeros would be for this one? What do you think? Well, feel free to go into Desmos and graph this and see what the zeros are. I think you'll be pleasantly surprised that it actually makes some sense. All right, last example in number 1 is D. You'll notice right away there's a cubed here. That's bad. There's a number out front. That's also bad. But if I gave you this question yesterday, you would have just common factored. So let's common factor, see what happens. 3, okay, 3 divides into everything. Y cubed, y squared, y, every term has a y as well. Okay, so we take out a common factor first. Now, we do 3y cubed divided by 3y. I'm going to get y squared. Negative 21 divided by 3 is minus 7. Y squared divided by y is y. Negative 24 divided by 3 is negative 8. And y divided by y cancels. So we've common factored it. But in here, we now have a normal looking quadratic. They're y's instead of x's, but that shouldn't matter. So now what we have to do is we're going to have two sets of brackets, just like all the other ones. And we need two numbers that multiply to -8 and add to -7. So if two numbers multiply to a negative, we've got a positive and a negative. So let's divide by 1. So we've got +1 minus 8. We've got -1 plus 8. We've got 2 and 4, positive and negative, -2 and +4. And now we need to find which pair of numbers adds to -7. So let's try from the beginning here. 1 minus 8 is oh, it's that one. Okay, so we get y, not x, plus 1, y minus 8. And that, I think, is about as hard as the homework's going to get for you tonight. So let's skip on to see what's next. That's it! Okay, that was all the examples I had for you until homework time. And the homework is right down here. Okay, so there's the homework, page 211, 3, 4, 7, 8, 9. Again, as always, the amount of homework you do is up to you. I really encourage you to try this stuff. Don't leave it all till one day to do all 3 lessons. Ask questions if you need some help. I can set up a phone call. I can try to do like a Google Hangout or a Google Meet where we can talk and I can sort of show you stuff live via a video camera. I have like a sort of tabletop camera thing. So I'm sure we can figure something out. So please do this stuff. And as you're doing the lessons, don't just watch me do it. Pause it, try it yourself. And I think you should be able to get through this just fine. All right, folks, good luck. And please don't hesitate to reach out to me if you have questions, etc. And in terms of assignments and tests and things, I haven't given you anything yet. This is all just like normal lessons. Do some homework, practice stuff. Assignments will come. There might be like an assignment posted in Google Classroom. I'll give you notice. It might be like a Google form that you fill out, like a multiple choice quiz. I'm not really sure. I don't know the best way to grade you in this way. So I'm still trying to wrap my head around that. All right, folks. Good luck, and we'll talk soon.